Okay, welcome to our lecture video series on chapters 9 and 10 dealing with functions, and you'll forgive me if I'm sort of incoherent because I'm in some pain and I'm on some pain medication, but I'm doing the best I can. Work with me and we'll get through it. Okay, so here's what's going on. We're going to be looking at functions. What is a function? Well, a function is some way to encapsulate code that you can reuse. All right. Now this is leading us later on in other classes like 285 and 212 into object-oriented design, where you have methods that are part of classes. But here they call them functions. That's fine. It's the same idea. So what you do is, instead of having a bunch of code in here to do the same thing for 3 or 4 times, you can encapsulate it down into a function. And so I've got this example is called calculate area. Now I'll explain some of this to you in just a minute, but for now let's just look at this. I've got length, width, and area, and this is something we don't need anymore. I forgot to take it out. Those are our 3 memory locations where we're going to be either grabbing something the user and storing or calculating. So the whole point of this little endeavor is to get the length and the width of a rectangle and calculate the area, which, as you know, is length times width. Now I could easily come in here and after I get the length and the width and just calculate length and width and multiply length times width, and that would be my area, and output it and be done with it. Well, great, but that wouldn't show you how to do what we need to do. Okay, it wouldn't show other aspects of this, like polymorphism. You can use the same name of a function multiple times as long as the argument list, which we'll talk about in a minute, varies. It's a little bit different for each one. The compiler will go through and pick out the correct one based on what the argument list says. All right, so here's my little output, little wimpy output thing, and I've got please enter the rectangle length, CN length. You know that already, and there's the width, and I've set my precision just for for the heck of it. Now, here is where I would normally do my calculation. I would say area, assignment, length times width, output, and be done with it. Well, that wouldn't do us any good. So let's look at what we're doing here. Let's first look at what's called a value returning function. All right. If you'll notice here, I've got a function header and the body, right? And with what delineates the body is open, closing, curly braces, just like any group of code. If you want to, sort of link it to something, you have to have those. So that's called code block. And when you see a value returning function, the first thing you're going to see over here is the value data type, which it's going to return back to the caller, which is in main in this case. Now, a lot of this is just you're sort of rehashing it. We did it in 150, but some of you may not have had 150, so we're going to go through this again, and it's a refresher for the rest of you. So this is a value returning function. Now, how do I know that? Well, it has a data type here, right, of type double that's going to return, and it also has a mandatory return statement. All right, you with me so far? Okay, so this data type, the return type for the return value, has to have a match up here. So if I'm going to be returning a double, whatever I'm going to be returning it into has to be of type double as well. All right. Now this is what's called the argument list. Well, let me back up. Here's the name of the function. I'm calling it calc area. You can call it whatever you want, and that would be fine. In this case, I'm calculating the area, so I'm calling it calc area. Now, this is what's called the argument list. Some books call it the formal parameters list. Some books call this the actual arguments. It's the same thing, okay? You can have no arguments in here, or you can have 50. You have as many as you have memory that will compile. Now, the problem is if you've got more than 5 or 6, you probably need to rethink this and break it down into 2 separate functions. I have 2, 3 sometimes. And then you need the data type. So they are comma delimited. By that I mean I have 2 arguments in here separated by a comma. If I had 3, I'd have the first argument, comma, second argument, comma, and third argument. Okay, so that's the argument list. This is the function name, and this is the return type, because we're talking about a value returning function here, and it must have a return statement. So I've declared a local variable, local to the function, which means you can't see it up in here. It only exists while you're in here. of type double, and I'm assigning length times width into that, and then I'm returning that value back. Well, notice that's a double, that's a double, and area is a double. I could also do it like this. I could not have this and just have return length times width. That would work too. Well, actually, it would be len times width. Change the name of these since I wrote that. All right, that would work as well. You don't have to have this intermediate step. I just did that for discussion purposes. Okay, the next thing is we're in main. We've got length and width. How are we going to call this function, or as they say, invoke this function? Well, if it's a value returning function, you guess what you use? The good old assignment operator, right? What's the rule for an assignment operator? Think about it. Do you remember? Well, here it is in case you've forgotten. When the compiler sees this, it says, okay, I've got to have one value over here, and once I do the logic or the math or whatever I got to do to get that one value, then the value over here gets placed into the memory address pointed to by the name on the left, which is area. So if I drew a rectangle for area, I'd have whatever was on the right over here. Well, I don't have one value over here right now, do I? I do not. But I do have a method call. So it's going to have to resolve this down to one value before it can make this assignment. Sound familiar? So what's going to happen is when it gets down here, it's going to see it doesn't have a value, but it does have a value returning function. So execution is going to jump down here and pass in my length and width from main into here. Now, that brings up something else we're going to look at in a minute. The default way this takes place, the mechanism for this, is called passing by value. All right. Now, this is very important for you to remember what I'm about to say and understand it. What happens is when this call is about to take place, it takes, I got length here, right, and width here. It's going to grab copies of what's stored in the length memory location that we put in there from the user, and the width memory location is going to pass those copies into here. Now, they're copies by default. I can do anything I want to length and width in here. It will not change what's taking place in here because what I passed in were temporary copies. And what happens is this the compiler, when it, or the actual program when it's loading, it has been compiled in such a way that it allocates memory on the stack, which is different than on the heap. All right, this is done in general RAM. These are done on the compiler stack, which is very fast memory. So they're temporary, but they're real fast, okay? These only exist as long as this thing is alive right here, this method, this function. Once this return happens, these are gone, and that is gone because they are local to this method. They have method scope, all right? So remember that the default way that values are passed from one function to another, and main is a function, right? And it returns an integer to the operating system. There's your return statement. Is by value. That means simply that they're copies. I could add one to len here, and that's why I call them something different. I could call them the same thing, but it'd still be two different variables. These are temporary. I can do anything I want. I say len equals len raised to the 12th power, and when it returns back, length is going to be the same value it was that they gave me because these are temporary. They don't impact anything in here. They only exist while they're just there as a mechanism so you can get this calculation done, all right? That's the default way. All right, well, let's run this thing, and I'm going to run it to here and put some breakpoints in. Now, notice that I've got three methods or functions that are called the same thing. Well, how's that possible? You can't have three variables of the same name. Well, the reason it works is something that we call an object-oriented polymorphism. What does that mean? Well, it's Greek. It's if you split it up into two English words, you have poly, meaning many, and morph, or morphism, meaning to change, okay? Many changes or many instances. So the compiler will look at this argument list and decide which one of these to call, depending on what I pass in. So that's a really interesting thing, which can be used to your advantage in many, many ways, as you'll see later on. Okay, so let's go ahead and run this thing. Hopefully I don't have any errors here. We'll talk about function prototypes in just a minute. That has to go at the top, and these are declarations. They must go at the bottom of main. So these go at the top of main, and these go at the bottom. And that's in C++. All right, so let's run it, and let's see what we've got here. All right, I'm going to put in a 2 and a 2. It's going to break. All right, there's my function call. Now notice this assignment cannot take place because there's nothing over here yet. In fact, I'm going to see if it'll let me do this. I'm going to add a watch for that whole thing. Okay, so it's going to go F10. It's going to step down it. Notice what it did. The compiler looked. It said it's got 2 arguments of type double. It looked at all 3 of these and found that this was the correct one, and it called it. All right, and it passed in 2 for len and 2 for wid. Now these are temporary, but we're already into this method, so they exist at this point. I'm going to go ahead and add these to the watch, and you can see there's a copy of my 2 and my 2. That has nothing to do with these 2 values stored at length and width. These are just copies. We just pulled them out because we used the name just like you always do, and passed copies of them into here. So A is declared locally, so that's a double. And as you can see, as soon as this multiplication takes place, A is equal to 4. Before it was some garbage number because it hadn't declared it. All right, so now this return statement is going to return what? A double 4.0. Okay, because that's what the return type is, and that's what this is. That's what it's expecting. And if you'll notice, areas of what type? Double. It all has to match up, apples and apples. All right, now let's step through it again, pressing F10. It's going to return back to my calling line. Notice it didn't go to this next line. And the reason it didn't is because this is all in suspended animation, because this assignment still has to take place, which it has not done yet. But now, if you'll notice, calc area has a 4 sitting over here. So if you, in your mind's eye, you could scratch that through and put a 4. Now I have area assignment 4. What's going to happen? Area is going to get 4 assigned into it. Let's press F10 and see what happens here. Notice it happened that way. Okay, and now it's going to output that. Okay, the area of the rectangle of the value returning function is 4. Okay, now let's take a break. I want you to sort of get looking at it. Well, before we do, let's look at this. Now, function prototypes occur above main, and they're there because of, and I'm not going to get into this too deeply, but this is compiler theory, sort of. It's like, lightly dusting it off. I mean, we're not getting into it very deep. I don't know that much about compiler theory, but I know enough to be dangerous. What happens is this thing is compiled. It has to make a first pass through it. It makes several passes, and this is something that happens up front. In other words, what you're telling the compiler is, I want you to prepare on your second pass to allocate memory for some functions called calc area with various amounts of arguments and types of arguments. So this would, I guess you'd call it a pre-compilation, and it sets aside the memory so that when you get down into here on your second pass, it already knows how many of these there are. And then it starts doing local variables, which are easy to do. Okay, and there's actually a phrase for it. I just can't remember what it is right now, but maybe you know. Anyway, that's just to let you know why it's this way. Now, when we're doing GUI stuff, you don't have to have prototypes. It takes care of all that for you. So there's the function prototypes. All they are is the return type, if it's a return type, the name, the argument list, and the argument lists are always bounded. Open and closing parens is what bounds the argument list, and each argument separated by a comma. You can have 0 arguments or you can have 50. It just depends. I wouldn't go more than 5 or 6. And yet there's a semicolon there. Now don't make a mistake when you start getting down into here and put a semicolon after the header. That will cause you to have all sorts of problems. It doesn't go there. It only goes there when you're ending a line. I'm not ending a line. This is all one piece. Here I am ending a line. All I'm doing is saying, here's what to expect on your next pass. Okay. I will see you in the next video when we talk about void functions and passing by reference. Enjoy.